First of all, you need to understand certain things about the expression. The elastic energy of a wire is equal to, understand, a wire is equivalent to a spring. A wire is equivalent to a spring constant K equal to, can anyone tell you what is the spring constant of a wire? See, for example, there is a spring, okay? And you are applying some force F to the spring. What happens if the spring constant is K? What happens to the spring? Yes, anyone? It gets stretched, but then, say for example, you stretch it by X, okay? But the moment you release this force, what happens? There is a restoring force, isn't it? And that restoring force is directly proportional to X, is it? But it works against X. So you say that the restoring force is equal to minus Kx, is it? Isn't it? Yes. Similarly, if there is a wire, understand, very important thing, and you are applying some force to this wire, this was Young's modulus Y, the area of cross section is A, the length of the wire is L, fine. Can you tell me how do you define Young's modulus? Force per unit area divided by what? Delta L by, isn't it? So delta L again, for example, in this case, let me keep it X here as well, okay? You are applying some force F. So it stretches by X. Then this will be the expression, right? Correct? So what about this force? This will be equal to YA by L times X. This is the force which stretches it by X, is it? But the moment you release this force, what happens to the wire? It again comes back. And what is elasticity? Tendency to regain its original form, is it or not? So that means, if I want to introduce those restoring forces which are the reason for the stress induced within the wire, then that restoring force is equal to minus times YA by L times X, is it? Can you see this expression and this expression are the same? By comparison, can I say every wire behaves as a spring of spring constant K equal to YA by L? If you know the Y of the wire, if you know the area of the wire, if you know the length of the wire, you can directly find what? The spring constant, and then you can, everything what is true for your spring will be true for the wire. Is it fine? Can anyone tell me what was the elastic energy of a spring? Half kx square. Apply the same concept. Half kx square. X is given. You have to find k. For that you need Young's modulus, you need area, you need length, right? That's it. Is it clear? So now, if we want to find the work, that is the energy stored, that will be of course equal to half of YA by L, but x square, because that will be your displacement, right? The problem is we do not know y, we do not know area, we do not know the length, right? That is the problem. So we need to do a little manipulation. Fine? What manipulation will you do? You know that force is equal to what? YA by L times x. So YA by L times x is already F, correct? So W will be equal to half of YA by L times x is F, and then there is 1x left. You have everything, right? You have the force, you have the displacement, and you of course can divide it by 2. So the answer would be force is 200 multiplied by x, which is 1 times 10 to the power negative 3, and then you divide by 2. So technically it will be 0.1 joules. Is it fine? Clear or no? But my question is, if there is a wire and if you are applying a force 200 newtons and it stretches by delta L, how much work did you do? Yes, anyone? How much work did you guys do? Yes? Work is equal to what? Force times displacement. Isn't it? So what work did you do? Force you applied 200 and the displacement was 1. For example, it was F times x, isn't it? But when asked to find the elastic energy stored in the wire, what are you doing? You are doing force times displacement, but then you're dividing it by 2. So isn't it the half of what you did? Is it or is it not? My question is, where did this half go? This is the external work. This is the energy stored within the wire. My question is, where did this half go?
Changing the shape.
Is it clear, first of all? So if you just knew work is force times displacement, actually the stored energy in this case is always half, fine? So you can directly find it. Otherwise, if you don't know anything, just remember the expression that your spring behaves similar to a wire, or a wire behaves similar to a spring with spring constant K, and that K is equal to what? Y by L. If there are several springs connected in series, you used to find K effective, K in series, K in parallels, right? There might be wires connected in series, connected in parallels. Can you find their effective Y? Why? If you are able to find their effective K, you can find their effective Y as well.
Yes.
Isn't it? Clear or not?
Yes.
Come on, do this now. Is it clear? अरे ऐसे होगा ना तुम भी अजीब हो रहा है. There were two springs in series, for example. K1 and this is K2. What is their effective K? In series, yes. Oh, sorry. My dad is calling me. Hello? हाँ अबू हाँ अस्सलाम वालेकुम कुछ क्लासेस में तो तेरे वापस Have you done work energy power? NEET here. Work energy power, you did something with springs. How did you find effective spring constant? Okay, do you know? Okay, let it be. If there is a. What is the time period of oscillation if you just stretch it? What will happen? If you just stretch it, what will happen? It will come down and then it will go and then. Isn't it? My question is, what is the time period of oscillation? Uh-huh, 2 pi root L by G.
Yeah.
ये ऐसे घूमता है.
Yeah.
Isn't it?
Yeah.
For this, there is a restoring force, isn't it? And that restoring force is equal to minus K times X if the X is the displacement, right? So you know restoring force will be mass times acceleration will be minus K times X, right? So your acceleration comes out to be minus Kx over m, right? So acceleration is opposite to your displacement. When such a thing happens, remember this confirms simple harmonic motion. Okay? Simple harmonic motion means to and fro motion but periodic. Fine? The general expression for simple harmonic motion is A is equal to minus omega squared times x, where omega is the angular frequency. If you compare the expressions, what do you see? Don't you see omega square is equal to k by m? Yes or no?
Yes.
This is the general expression for simple harmonic motion, okay? If this is true, because you see it here as well, then this is simple harmonic motion, fine? Now here you see A is equal to minus omega squared x, this is standard equation. This standard equation has been used here. We confirm omega square will be k by m. So omega will be square root of k over m, isn't it?
Oh yeah.
But what is omega? 2 pi by?
Answer.
Isn't it?
There.
So that will be equal to square root of what? K over m. Therefore you can find the time period. Time period is equal to 2 pi square root m over k. This is the time period of oscillation of a spring with spring constant k, and there some mass was attached to this spring. Okay? But my question is, if there are two springs instead of one, and then this mass was connected, how will you find the time period of oscillation? Who is your regular teacher?
Sir. But before that it was somebody else.
Who taught you work energy power? If there is a spring and you cut it, the spring constant was k. You can't cut it into two pieces. So one will be this and other is this. What is their effective spring constant? Is it k? Okay, tell me. Is a smaller spring very difficult to stretch, or a bigger spring?
Smaller.
You have those. How many of you have these? No, the motorbikes. These.
Electric scooters.
Okay.
Huh? Electric. So they have that side stand.
Yes.
They have a spring.
Yes.
It's very difficult if you pull it with your hand, but then you have to apply a force with your foot, isn't it?
Yeah.
So that means smaller springs are very difficult to be stretched, isn't it? Not the one in the pen. That has a different concept actually. The one in the pen has a k value which is very small. Okay, I'm talking about a single spring. That is the spring of the side stand of your electric scooties. Fine. If you cut that spring, a smaller, even smaller spring, isn't it? You will obtain. Will that be difficult to be, stretched, or will it be easy to be stretched? More difficult, right? So, does it give you the idea of k? After cutting a spring, does its k increase or decrease?
Increase.
So it is 2k here. It is 2k. Because once you connect back, it will become k. So therefore, when springs are in series, remember it is equal to 1 by k1 plus 1 by k. It is equivalent to resistors in parallels. Is it fine?
Yes.
So sometimes springs might be connected in parallels. There are two springs, they are connected in parallels. Say for example, now I'm applying some mass. Someone tells you, what is the time period of oscillation? In that case, you will obviously write down the general expression 2 pi square root m by k, isn't it? But this time which k has to be used? So what? The k in parallels. So in parallels, kp is equal to k1 plus. It's always the summation. Is it fine?
Yes. Sure.
That time you can use it here. So that is what I was telling you. If you are able to find k effective, you will be able to find y effective. Isn't it? Say, I'll give you an example now. For two springs, can I say equation is simply k1 k2 divided by k1 plus k2?
Yes.
Remember these things. Same applies to wires now. Okay? For example, you have two wires. One is this and the other one is this. Y1, Y2, L, L. Area A, area A. Fine. The question is, if I make a single wire, what will be its Y effective? Okay? So first of all, if I make a single wire, let me find its effective K. Isn't it? So for K, we have an equation YA by. What about K1? It will be Y1 A by L, isn't it? What about K2? Yes, Y2 A by. Because they are in series, what will be their K in series? Product by. Product by. Isn't it? So let's multiply them. So it will be Y1 Y2 A square divided by L square, and then you divide it by their summation, right? When you find their summation, it will be Y1 A by L plus Y2 A by L. A by L was common, so this and this also cancel. Is it fine? Is it fine? So what are you getting? Ks as, yes, tell me. It is Y1 Y2 A by L times Y1 plus Y2. No problem with this? Is it clear? But then when you make an equivalent rod, it also has some K in series, and that will be equal to Y in series, A of the combination, that will still be A area didn't change, divided by what? L, but the length is?
2L.
Exactly, it's 2L. Is it fine? Is it fine or not?
Yes.
Then can I say this and this should be same?
Yes.
Khalas, that's it. Ys A by 2L should be equal to Y1 Y2 A by L times Y1 plus A by L cancels out. 2 वहां चला जाएगा. Y in series is equal to twice divided by. This is your Young's modulus in series for two rods. No need. I just gave it the touch of work energy part. It is you can still derive it if you don't know these formulas. No problem. Fine. But because you have done work energy power, you should be able to understand. Whatever is true for springs in series and parallel is true for rods, wires connected in series and parallel. Is it fine? So this was asked in JEE. Young's modulus for two rods and the combination. Okay? They're asked. Sometimes A1 and A2 will also be different, L1 and L2 will also be different, but still you have to approach by the same method. Is it fine?
Yes.
That time, be sure of what you are doing. That's it. Is it clear? Any doubt? Now I will have a question for you. What if two rods are connected in parallels? Yes. Did you copy this?
2 minutes, sir.
2 minutes.
Tell them to take screenshot.
Not very smart. It's okay. I forgot someone is in the online session as well, because you did not respond up till now while I was asking the questions. Is it fine?
Yes.
नेक्स्ट पैरेलल वाला करें. अब ये था नहीं कहीं पे, अब ये कहां से आ गया अभी मुझे पता नहीं, बट स्टिल वी कैन डू इट. If there are two wires, for example, okay, and they are connected in parallels, say y1, y2, L, L. Fine. And now what you are doing is you are trying to connect, you are trying to make a single wire out of it. Single wire out. The question is, what will be Y in parallels? Yes. What will we do this time? When wires are connected in series, they have their own individual spring constants. Yes, K1 will be Y1 A by L, K2 will be Y2 A by L. Is it? In parallels, it has to be simply added. So it will be Kp, that will be equal to what? K1 plus, that will be equal to, yes, Y1 plus Y2 times A by L. Is it? This is your Kp. But at the same time, this combination also has an equivalent K. That is Kp, which will be equal to, yes, Yp. What about area?
2A.
No, 2A. Area won't be same.
By L.
Because when you are combining two rods, 1 and 2, area is doubled this time. In other case, if it was A1, A2, then A1 plus A2. That's the difference. Divided by, yes, length will still be the same. Length won't change. Isn't it? Clear or no?
Yes.
Equate the two. Yp twice A divided by L is equal to Y1 plus Y2 A by L. A by L cancels out. So what is your Y in parallels? Yes. Y1 plus Y2 divided by?
2.
That's it. 2 JEE questions. Done. The fact is, how did you approach? And see, understand, when wires are connected in parallels, their effective Young's modulus is the arithmetic mean of their individual moduli. Is it? Is it or is it not?
Yes.
The arithmetic mean. Class 10th arithmetic progressions you have done. But now look at this expression here. Twice y1 y2 by y1 plus y2. This is the harmonic mean of the individual Young's moduli. So there are expressions known as arithmetic progressions. There are expressions called as geometric progression. What is the geometric mean, anyone? Exactly, square root of AB, isn't it? But then there is an expression called as the harmonic progression. The reciprocal of the terms are in AP. Okay?
Yes.
The reciprocal, for example,
1 by 2, 1 by 4.
yeah, 1 by 2, 1 by 4, 1 by something missing, 1 by 8. If you're asked to find this, what do you have to do? Twice 1 by 4, 1 by 8 divided by 1 by 4 plus 1. That is your harmonic mean. Is it fine? Don't you see that the expression is somewhat similar to that? So it is the harmonic mean of the individual Young's. Is it fine?
Yes.
Clear?
Can you show the other slide?
Yeah, of course.